Welcome. Thank you all very much. Firstly, for the honour that the institution has bestowed on me in making me its president for a year, and also for coming to this presidential address. It's good to see so many old friends, some of whom I've not seen for quite a long time. It's also good to see a really good contingent from my own university, the University of Surrey. Particularly, I have to say, my new boss, Professor Max Liu, who's the new Vice-Chancellor of the University of Surrey, who is himself a distinguished chemical engineer and the former Vice President of IChemE Australia. So welcome to you all. So in thinking about what I was going to say today, it seemed to me that the most important word was relevant. I think we would all like the discipline of chemical engineering to be and to remain relevant and to grow in relevance. And we would all like the institution of chemical engineers to grow its relevance. None of us likes to be irrelevant. So how do we make sure that that happens? How do we make sure that chemical engineering, both the discipline and the institution, remain relevant in a world that, as we know, is changing extremely rapidly? So it seemed to me that we need to consider what the value of chemical engineering is, both the discipline and the institution. And I've offered a few elements there of how one might regard the value of the discipline and the value of the institution. These days, governments tend to regard the value of everything in economic terms. So there we have the economic value of the discipline. Clearly, there is a strong economic value of the discipline. There is a scientific value. There's a set of principles that have been developed over nearly 100 years, in the case of IChemE, that encapsulate what we know of the science of chemical engineering, and we are adding to that all the time, of course. There's an intellectual value, and anybody who was at the Energy Centre meeting yesterday will have been thrilled, as I was, to hear from Professor Roland Clift about how the principles, the intellectual content of chemical engineering can be applied in areas way outside what we might consider of as traditional chemical engineering territory. In his case, the contents of your wardrobe, the amount of stuff in the economy. And then I think there's a cultural value, which we might talk about later on. For the institution, clearly the institution exists to maintain the standards that and we guard those jealously, and I'll say a bit more about that. But the institution is also a very useful network of people doing the same kinds of things, of exchanging knowledge. And we shouldn't forget that, of course, the professional institutions started as a means of exchanging knowledge between people who were doing the same sorts of things, building and operating steam engines, for example, who simply needed to swap information about how you could make things work. And that's still an extremely important element, I think, for what we do. And of course, increasingly, we're a sort of a lobbying organisation. We're an organisation that has a view on things and wants to promote that view for the good of society. This is an interesting point to be taking over as president. It seems to me that there is a bit of a crisis going on because we've seen a precipitous fall in the price of crude oil in the last year and a bit, reaching lows, as it says here, last seen in 2004. And that has had some pretty serious consequences for those of our members who are working in those affected sectors. And I'll show you the results here of a survey that the IChemE has done of its members, broken down by area of the world. As we know, and as we've heard again this afternoon, the IChemE is a global organisation operating in many parts of the world. And the way that different parts of the world see this crisis is of course different. It's had a very big effect in Malaysia. The red here is the proportion of members who replied to our survey and said that they had been affected negatively by the fall in the oil price. Clearly, it's had a rather smaller proportional effect in places like New Zealand, where the economy is somewhat differently based. But that's a big proportion of our members that has been negatively affected. How have they been affected? Well, we asked them that too, and you can see, well, I'm pleased to see that not many people have said that they have cut health and safety. I'll come back to that. But there's reduced investment and production, the projects cancelled, recruitment freezes, job cuts. I was very sad to see the red bar against student placement or that will be people in part-time positions and experienced positions for students. That's short-sighted, and we need to try to make sure that even in these difficult times, companies don't do short-sighted things like that. But there's hurt here. Our members are hurting as a result of what's going on. Here you might be interested in the current IChemE membership profile, which is relevant to the slide you just saw. 24% of our members are working in oil and gas exploration and production. Now, I think this plot here is a challenge to us. And whilst it's good to see strong membership in the oil and gas related industries, it's not so good to see that only 5% of our members are in water, 4% pharmaceuticals and personal care, and so on. This is a challenge to us. I think there are some sectors there that we should be trying to grow our membership in. And I know that we are. But during the time that I'm president, I'm going to be working particularly hard on trying to grow the membership in some of those areas towards the bottom of the diagram there. We've been here before. Now, what do I mean by that? We've had crises of various kinds before, and thinking about the crisis of the oil price right now made me think about my own personal crisis, if you like, of a slightly different kind. And it took me back to the University of Birmingham, where I was head of chemical engineering in the year 2000 and the years leading up to that. In fact, I became the head during that period, 96 to 2000, and those were the intake numbers to chemical engineering courses in the UK for that period. And this looked pretty bad. And my boss at the time was drawing various kinds of lines through these points and suggesting the point at which perhaps we might be merging chemical engineering with other disciplines or getting rid of it altogether or whatever. And in the year 2000, we invited to speak to us a very interesting man called Hans Wesseling, who had the best part of his professional career at Shell, designing distillation columns and things of that kind. Then saw the light, as he would say, I think, moved to the University of Groningen, and then did work also in Denmark, at the Technical University of Denmark. And he came to talk to us about his view of all of this. And this stuck in my mind. The world is changing, but we are not. And what did he mean? Well, he told us a lot, but here's some of it. So he contrasted the way the world was in 2000 with the way the world had been in 1970. He talked about the oil price. He talked about what he saw as the decline of fundamental research. He meant the closure of big corporate research in the multinationals. He talked about how chemical engineering was not done the way it used to be, with reactions done in test tubes, turning into small-scale lab developments, turning into pilot plants, turning into larger plants and larger plants. Developments that took years, in some cases decades. That wasn't how chemical engineering, in his view, is now being done. that everything is being done together, concurrent, no time, everything is being market-driven. Unless you can respond really quickly, it's too late. You don't develop everything yourself, you develop it with others in multidisciplinary teams, and so on. This was a really inspiring lecture that we had from him, and it told me, I think, that it wasn't only the content of chemical engineering that was changing and the applications to which it was being put, but the whole way in which chemical engineering was being practiced was changing. And I think we've seen that extended and developed from that point. And he was right, and he saw this very early on. And one of the most important things he said to me was, this subject isn't just about the process, you know, it's about the product. And it's about the way the product is used. It's about the way the product interacts with the consumer. It's about product attractiveness. And there's a lot of good chemical engineering that can be done there, which you aren't addressing. And that was a useful point, I think. Now, also about that time, we had a lot of assistance from this company, from Unilever. And Unilever, I think, I don't know whether there's anybody here in the audience today from Unilever. There is indeed one person I know, Goping Lian, greetings, who is here from Unilever. Unilever is a challenge, I think, to the Institution of Chemical Engineers in that it's a big company with 170,000 employees worldwide, I think. 40 billion pound global revenue. It spends £500 million a year on R&D. So my question would be, we know that chemical engineering is hugely relevant and is, to use the words we were using in the council meeting a little bit earlier, the discipline of choice in companies like Shell or BP. Is it the discipline of choice for Unilever? Is it the most useful discipline that Unilever knows about? Well, there are members, there are good members working hard and doing good things in Unilever, but we're there in a company like Unilever or Procter & Gamble or Nestle or GSK or Merck Sharp & Dohme or Pfizer. Chemical engineering competes with other disciplines in a way that it doesn't have to do in some of its heartlands. And I think we need to be competing harder there, and we need to be training our students so that they can compete harder there, and we need to be doing the things that are relevant to the sorts of companies that Unilever represents. Apologies to Unilever if they feel sort of picked on here. They're an example. And what changes has Unilever seen? Well, Unilever makes products, and its products have changed from being homogeneous things to being composite and structured. And, well, I won't read it all out, but you can see the kinds of changes that have occurred in the products of companies like the ones that I've mentioned. Now, some people at this point might be saying, why is he saying all this? Because it's been said many times before, hasn't it? Well, yes, it has, I think. There are many people that are as keen as I am on developing this area of chemical engineering. But I still feel as though we have a long way to go here to convince people that there are areas of chemical engineering that are perhaps outside what they feel is comfortable and natural to them. This is a consumer-led area, and it shows rapid market changes, and the way that chemical engineering is done is different from other areas. So, is chemical engineering education keeping up? Well, back in 2000, Hans Fessling said the traditional chemical engineering course qualifies its graduates to build an oil refinery. Well, there's no disgrace in that. If you come out of a degree course knowing how to design an oil refinery, that's not a small thing. But you can tell from what I'm saying that there are other things to come out of a chemical engineering course knowing how to do. And he clearly felt at that time that we weren't taking enough account of what we should be doing here. I hope we've improved. I think we've improved. What we did in Birmingham was to develop what we sort of called a new discipline, formulation engineering. Actually, of course, it's not a new discipline. It's a branch of chemical engineering. And it concerns the manufacture of chemical and biochemical products sold by a function or effect, chemically complex, physically structured. How is it different from chemical engineering? Well, it employs exactly the same skills, I would say, but it focuses much more on the product properties and the product-process interactions. And if people, what I normally tell the students when we talk about this kind of thing is, an example, if you pump water around a circuit, it doesn't know where it's been. It's still, it has no memory of the events it's been through. You can evaporate it and condense it again. It's still water. Try doing that kind of thing with yogurt or with other bio products. It knows very much what kind of process it's been through, and it's a different product when it's been through that process. There's a lot of complexity there, which traditional chemical engineering courses have not addressed. And I think we need to address those things because there is a lot of money to be made and good things to be done in those kinds of areas. What I think this subject area also does is it concentrates on the, as I've said, the product usage and the life cycle and the environmental consequences of those things. I'm a bit stuck here. Here we are. So, where's the intellectual challenge? Well, here's one slide from the inaugural lecture that was given by Professor Mike Adams. Interesting story. He transferred from Unilever to the university sector and became an academic. Allows me to say that I think we should be doing everything we can as an institution to encourage people, practitioners in industry, to work in universities, and of course to make that happen the other way. There are schemes, they're not much used actually, and we should try and make sure that more of that kind of exchange happens. Here are a few of the intellectual challenges in trying to deal with products of a granular nature, which is a particular area of interest to me. So this thing called formulation engineering, if you wanted to say where is it important, here's another diagram from Wesseling that considers products all the way from bulk products like oil to very fine scale specialities like analytical chemicals, and gives you some idea of where this kind of sub-discipline fits. And you can see there's a whole swathe of product areas there where there's a lot to be done and many people employed. I have no time to describe how education in this area really works, but a number of places around the world now are trying to get students to understand what goes on in these fields by project work. The best way of understanding, I think, the way that formulation engineering is done is by project work. And this came directly from a student submission. Some students using common food mixers were able to make detergent powders of the kind that Unilever makes, according to different formulations and different processes. And this is the diagram that they drew. And I like it because, of course, it's not just about the manufacture. In fact, it starts with the manufacture. It's about packing and storing and what the customer thinks of the product, a whole list of desirables in the product. And the project, of course, was all to do with how to make those desirables appear in the product. And it's about how the customer uses it, and it's about what happens when this thing goes down the drain and the environmental consequences of that. Nice student project. So, around that kind of time, the early 2000s, of course, Why Not ChemEng got going. And I think it's no coincidence all these things were happening at the same time. And a lot of us were saying, Why Not ChemEng is sort of about trying to convince potential students of chemical engineering that there's a multiplicity of futures for them. This isn't just about oil and gas, it's about lots of things. You can apply your skills in lots of different industries. And I think we won on that one. I think, well, clearly, Why Not ChemEng was extremely successful. We can argue about exactly what it was in Why Not ChemEng that made it successful, but a big element for me was convincing people of how widely applicable their chemical engineering skills would be. And you can see, you can't argue with the results. The results are really impressive. This is the UK undergraduate intake up to the present time, and that continues. It's the fastest growing engineering subject in the UK. Fast forward to 2022. This is not, as somebody thought earlier on, IChemE's plans for its new headquarters. This is actually to do with another event that's going to take place in 2022 in Qatar, Artist's Impression. We're coming up to our centenary, and it's going to be an important part of my job as president to initiate the planning for that centenary, which will take some time to get to, of course. There's much we need to do. What can we look forward to happening between now and then? Well, here's a subject which I think we need to talk about. We were talking about it yesterday in a meeting that was held as part of the Energy Centre event, which I thought was really very interesting. Is industrial ecology, what is this thing, industrial ecology? Is it a new discipline? Well, if you read what it says about itself, it says it's about studying the flows of materials and energy in industrial and consumer activity and the impact of those flows on the environment. And it talks about economic factors and political and regulatory and social factors, which you don't always see in a chemical engineering course. But a lot of this looks very like chemical engineering, doesn't it? Here's a man who's involved in it. He's sitting over there. Can't really make a presidential address without mentioning this man, since he taught me all I know. Well, about some things anyway. This is Roland Clift of the University of Surrey, for those who don't know him, who was at one time the head of the chemical engineering department there, and then set up the Centre for Environmental Strategy, and now has the role as president of the International Society for Industrial Ecology. Again, this is what it says about itself. These are the things that it says that it does. And interestingly, I like the statement at the bottom, uniting these elements is attention to the flow of materials and energy at multiple scales. And it lists the scales all the way up through facilities and groups of facilities to firms and cities and regions and the globe. And I think that's nice. But it's definitely chemical engineering in my book. So this is surely a discipline that we should be embracing as an institution. And just to tell you a bit more about it, I think this sums it up really well, because this is Kalundborg in Denmark. This is a fully integrated complex of firms and undertakings that exchanges energy, exchanges water, exchanges materials in a way that minimizes waste and is most intelligent. We read in the press these days and in Research Council documents quite a lot about smart cities. Too often it seems to me smart cities actually means somewhere where you can find a parking space and the traffic is properly controlled. This is a really smart city in my book, and there it is. It's beautiful. So this, the planning of things which are bigger than a single facility, and the design of things of this kind is surely another area where chemical engineers can bring their skills to bear. And I'd like to see us getting much more involved in the planning for what you might call smart cities. I've tried to make a small contribution in this kind of area myself a bit earlier in my career in setting up a company which is trying to recycle waste plastics. This is a pretty critical problem, and a recent study suggests that by 2025, I think it is, the weight of plastic in the oceans will be about 1/3 of the weight of the fish in the oceans. By 2050, they'll be equal if we carry on the way that we're going. So what to do about oceans of plastic? Well, let me just show you a quick clip from a company called Recycling Technologies, which I helped to found. I can't take a great deal of credit for what they've done since. They were finalists in the IChemE Global Awards a little bit earlier last year.
I'm Adrian Griffiths. I'm the CEO of Recycling Technologies. My role is to try and make sure that the overall organisation comes together to actually do something great with mixed plastic waste.
My name is Matt Green and I'm the Engineering Manager at Recycling Technologies.
The problem that we're trying to solve, and this is chemical engineering at its very best, is the problem of what we call mixed plastic waste.
In 2012, around 25 million tonnes of post-consumer plastic waste ended up in the waste stream. Only a quarter of this was recycled.
And the solution, of course, is to actually put value back into a problem material. What we've actually come up with here is a way of taking that mixed plastic waste, which is a liability, and turning it into an asset, which is plaques.
We've now designed our first commercial scale machine. This is able to process 700 tonnes of mixed plastic waste per year.
You can make virgin quality polymer that has recycled content. And I think that's really, really exciting because it takes plastic, which is a great material, and turns it into a sustainable material. A material that we don't have to be apologetic for its use. We can use all of the upsides of it because we've conquered the downsides.
So they're doing a great job at Recycling Technologies, but I put them up there partly as an example of quite an exciting startup which has gone from zero to what you see, something which is merely commercial, in a short time with, I think, chemical engineering principles at the heart of it. So for me, I want to see some wider application of chemical engineering. I think 21st century chemical engineering has got something interesting to contribute in the structured products area. It's certainly got something really interesting to contribute in industrial ecology and symbiosis. I haven't said anything really about systems analysis and optimization, but clearly that's key to developments like Kalundborg. And that's another area where we have a lot to contribute outside our traditional heartlands. So I wanted to move on then to the second part of my talk to address what I think the professional engineering institutions need to do to retain their relevance. And I mean all of them, not just IChemE. This is a quote that I particularly like. If you don't like change, you're going to like irrelevance even less. This is a quote by General Eric Shinseki, who was the first Asian American four-star general in the US Army and has tried to do something to reform that enormous organization. Here's another ex-military man, Nick Bavistock, who's the chief executive of the Institution of Civil Engineers. And he led on the production of, I think, a really stimulating document about the 21st century professional engineering institution, which our own chief executive, David Brown, also contributed largely to. And what he was trying to do, or what they were trying to do, was to address this question of whether the current professional engineering institution model provides the best, most efficient service for our members and for society, which of course is what we are bound to do. The professional institution world is changing. New generations, as I know myself, since I have daughters of this kind of age, don't want what was offered before. Many of the jobs that we recognize at the moment are going to disappear in the next 20 years. We're all global in some sense. There are a lot of changes happening here that I think we will all recognize. The last one is interesting, actually. Local, bespoke, and personalized is the new big business. What this means, I think, is that, and I've taken all of these from elsewhere, of course, what this means is that companies like Amazon, as we know, are now able to understand so much more about us as individuals that they can tailor what they provide to us exactly to what we want and when we want it. Well, the IChemE should be doing that, shouldn't it? And I think if we carry on the digitization project that we have in train, it will do that. We aren't there yet, but we will be providing, I think, a much more personalized service to our members. So IChemE is going through a strategy revamp, which I think will result in addressing many of these issues. What are the challenges? Well, IChemE is a volunteer organisation. People are busier and are not able to give that time perhaps quite as easily as they used to. People challenge value in this area. I've talked about the generational effects. There's competition. There are other organisations you can join, which you may find are more attractive for one reason or another. The technology by which we deliver what we do is changing. And as we've said, globalisation is a big opportunity, but also a big challenge. Operating an organisation like this, I mean, after all, the number of permanent staff at IChemE is relatively small, but we are trying to operate simultaneously in many different countries around the world and to offer good services to all of our members in all of those places. And that's clearly going to be a big challenge for us in this boundaryless profession, as the previous president called it. Nick Bavistock, whom you saw earlier on, his committee listed what it called the duties of a professional engineering institution, and these are they. Now, I don't have time to cover all of these in detail, but I'm just going to pick up a few of those from that list of public safety, transparency, the learned society duty, the duty to attract in the next generation, to do research, and to operate, of course, efficiently. Public safety, it's right that that should be put first, of course, because if we have a primary duty to society, it is surely to be able to operate safely. And we jealously guard the way that we do that. The competence and commitment test, which is the evidence by which we award chartered chemical engineer status through our license from the Engineering Council. But I think we have to challenge a few things here. For a long time, the way we've done this is through interviews, peer interviews. That seems to work well. I think when we ask our members what they think of how we should operate, on the whole, they feel that peer interviews would be better than robotics or whatever else. But if we are going to increase our membership as much as we want to, this is going to be a challenge, because finding enough people to do peer interviews is going to be difficult. So we have some challenges there. And I think we also have to challenge ourselves a little bit on bias in interviews, to be honest. I asked in all instances of all of the professional engineering institutions, not just IChemE, what was the pass rate in the interviews for chartered engineer? And it's pretty close to 100%. It's well over 90% in most. The exception being structural engineering, actually, where there is a long and complex examination to take. So I said, well, this is easy. This is probably too easy, isn't it? The answer was, but people only come up for their interview when they're ready. So there is a sort of mysterious process in which people get ready and come for the interview and mostly are accepted for membership. What goes on in that process? I'm quite interested in that. And are we putting people off there? And what happens to people whose qualifications are not straightforward first degree chemical engineering, and so on and so on? There are some questions to be asked there, I think. And I'm pretty clear that the answers mostly will be really satisfactory, but I think we have to look at that. Another big question, should continuing professional development be compulsory? Most of us, we got a qualification in chemical engineering and that was that. Well, I suppose academics might say they're challenged every day in their understanding of the subject. But we don't retest people in the way that we retest airline pilots and surgeons and so on. So are we really sure that we're keeping up to the mark? And I was really struck. I represent the IChemE on the Engineering Council. And I was really struck by a story that I was told about civil and structural engineering. This is the collapse of a building in Christchurch in New Zealand in 2011. Some of the buildings in New Zealand in that earthquake should not have collapsed and did, I'm told. They were designed by qualified structural engineers. And the New Zealand government, as I understand it, had an inquiry afterwards about what had happened and which buildings had collapsed and why. And the judge naturally asked questions about the qualifications of the people who designed the buildings. And it emerged that the judge had assumed that the training of civil and structural engineers was a continuous thing, and that one would always be designing to the latest standards and one would always be completely up to date. And was a bit surprised to hear that people get first degrees and then there's no obligation for subsequent continual professional development. So that struck a chord with me, and I began to wonder whether we should be making such things compulsory. Well, of course we are, and the Engineering Council is now obliging engineers to undertake continuing professional development and to record that. It hasn't started yet. It will start soon, but already the IChemE is being obliged to do sampling of the CPD activity of its members, and I think that's quite right. That's a development that I think is welcome. Just turning to another one of those duties, the duty to attract the next generation. Lots of initiative out there. We should be really proud of what we've achieved in the Why Not Chem Eng campaign. It's a bit old now. It was, as I said, it started quite a long time ago. There is a case for revamping it, I think, having another go, making the point again that there are many other areas where chemical engineering expertise is important. I can see Ian Schott nodding his head here, and I know what's in his mind, that we need to restate the opportunities in biochemical engineering and biotechnology, and we need to be attracting more people whose interests are in that direction, whose A-levels perhaps are in biology. So there is work to be done there. We have to ask, I think, whether the competition between the different engineering institutions and the scientific institutions is always helpful, and there's clearly a case there for working together on recruitment of students into STEM, not only in the UK, of course, but in all of the countries in which we operate. Here's some more data. Sorry, this is only for the UK, and I'd be very interested in what the comparable results are for the other countries in which IChemE operates. 25% of the applicants accepted by UK engineering courses in chemical engineering in the most recent year for which we have data are female. Gets worse in the other engineering disciplines. I don't think we should be particularly proud that we're doing better than those other engineering disciplines. I think we should be heading for a much bigger slice, actually. This should be 50-50, and it hasn't moved much, actually, even in the time that I've been teaching chemical engineering. So we're doing sort of okay, but not nearly good enough. This is another set of data which shows you the ethnicity of the people getting first degrees in different engineering subjects. What you see there is that the percentage declaring themselves as white in chemical engineering, amongst the chemical engineering first degree awardees, is 58%. And the other blocks, if you can't read the bottom there, are for black, Asian, Chinese, other unknown. This surprised me and pleased me, actually. This looks good, I think, for chemical engineering in the UK. I'd be very interested to see what the breakdown is in jobs. I think there's some concern that ethnicity, there's an ethnicity effect in employment, and I think we need to look at that. But on the face of it, I think this looks good, and it's something we should monitor. And here, I couldn't resist showing you the happy smiling faces of the young chemical engineers at the Frank Morton Sports, which the IChemE still holds every year, greatly enjoyed by the participants. And here's a nice group of budding young chemical engineers to give you some optimism about the future of the subject. Just before I finish, just a word about research. In IChemE, we had, led by Ed Daniels, the production of a very useful roadmap, I think, for technologies, chemical engineering matters, a while back. Since then, we've revived the research committee of the institution, and we've also revived the ChemEng Day in the UK, which fell out of use for a while, and I'm really pleased to see it back. And I was there at the University of Bath a bit earlier this year, and it was a really good meeting, very vibrant, and full of people actually from the newly started chemical engineering departments, Chester, Hull, Wolverhampton, places that are just getting started and were keen to participate. It's the last point which I think I have to think about as president, increasing our influence on funding bodies. And there, I think we have something useful that we can really do, because governments are slimming down. They don't have as many people to advise them as they used to do. They need good advice, and they need advice which is validated by the community. And they don't just listen to academics like me. Obviously they don't, because they expect that there's special pleading going on there. What they want to hear from is people in industry, actually. But even better than that, probably, is a combined approach by academics and industry. I think that's an area where we could do more, and that's certainly an area that I'm already working in and will do more in as president. So, to come back to relevance, we have to grow our relevance, of course, to a wider range of employers and other organisations, including governments. We have to prove our relevance to chemical engineers wherever they are in the world, which means that we have to understand the sorts of circumstances in which they work and the economic and social factors that affect them. We have to be relevant to young men and women of all ethnicities and backgrounds. I would really like everybody to be able to be a chemical engineer, if that's what they want to do. And we have more work there to do, particularly on gender, I think, in this country, perhaps on ethnicity in this and other countries. And we have to show our relevance to other organisations in the STEM area. And where there is common cause, we should be trying to work with them instead of in competition with them. So that's the summary of what I wanted to say. Things are changing around us, and we need to make sure that we maintain our relevance in this changing world. So thank you very much, ladies and gentlemen. As I say, I'm honoured to be your president for a year, and I hope I've given you some idea of some of the things that are important to me.